I'm Anil Kumar. Welcome to my series on trigonometry of compound angles. Now, this is dedicated to my beloved student who is an excellent soccer player but is kind of afraid of trigonometry. He doesn't understand alpha beta of this game. My attempt is only to make him understand it, and I feel many other students sailing in the same boat may benefit. So first part, which is kind of tough, is get all the formulas together. So this particular sheet, which you have been watching for last 1 minute, holds all the formulas required to solve any question based on trigonometry of compound angles, believe it or not, right? So that is all. And what am I going to do? One, I'm going to keep a very good eye on what you are getting and what you're not getting. So the small clips of that hawk which you see is my eye watching you, and not from the aspect of what you have learned, but from the angle of what I need to teach you so that you get the trigonometry of compound angles, correct? So I think you must have got a note of all these formulas. And once you've done that, these are the questions which we'll talk about. So we'll take 4 or 5 questions. The first one will be very straightforward. You need to express each as a single trigonometric function. We have 4 questions here. And then I'll take another kind where we are going to use the double angle formulas. And then we'll have another question where we are going to split the angle with the 2 combinations, apply the formula, get the exact value. And after that, we'll try to prove some things, very simple, only to get you used to the formulas which you saw. And we are going to use only the top 4 or 5. Rest we will keep for part 2 and part 3. Is that clear? So here at question number 5, we are going to stop. Correct? So let's begin with question number 1 now. Express each as single trigonometric function. We are given 4. And the formula to be used is very simple, which is sine A plus B is equal to sine A cos B plus cos A sine B. And if I have sine A minus B, in that case, the formula is sine A cos B minus cos A sine B. Perfect. As far as cosine is concerned, for cos A plus B, we have cos A cos B minus sine A sine B. Now this is important, right? So there is a change. Cos A minus B is cos A cos B plus sine A sine B, correct? We are also using the tan formula here. So let me give that tan formula also. So tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. The whole idea of writing the formulas along the way is for you to remember them, right? So if we have minus here for tan, these signs reverses. That is it. Now you should answer these questions yourself using these formulas. So let's answer one by one. The very first one is cos 3a cos a alpha, you can say, minus 3 alpha sine alpha. So this is cos A cos B minus sine A sine B. So that means we are looking into this particular formula. So the result should be sum of these 2 angles and cosine of that. So we get cos of 3 alpha plus alpha, which is equal to cos of 4 alpha. That is how you can easily solve it. Is that clear? Now we have something like sine, you can read this as sine A cos B minus cos A sine B. You get my point? Now, that corresponds to this formula where we are looking for difference of angles, and therefore this should be sine of alpha minus 3 alpha. Now that is tricky. Do not write 3 alpha minus alpha. Perfect. This minus that. And that gives you sine of minus 2 alpha, and sine of negative angle is negative sine 2 alpha. Do you see that portion? So if you interchange, you're going to get wrong result. So for this one, let me write it in a different ink. It should be equal to minus of sine 2 alpha. Perfect. Next question here is cos A cos B plus sin A sin B. So when it is plus here, then for cos, we are looking for difference of angles, right? A minus B. So in this case, we get cos of alpha minus 5 alpha. That clearly is cos of minus 4 alpha. However, cos of minus 4 alpha is same as cos of 4 alpha. Now the question comes, why so? Simple solution for you to understand is that if you have coordinate plane kind of like this, in that case, you know, all are positive in first quadrant, sine in the second, tan in the third, cosine in the fourth. Now when I say minus of an angle, that is to say, when I'm saying sine of minus theta, we are in quadrant 4. Now in quadrant 4, sine is negative, so it is minus sine theta. However, cos of minus theta is equal to cos of theta, since cos is positive in quadrant 4. So I hope that point is well taken care of. Now this is key, right? At times you may just do this mistake and lose all the marks. Okay, the next is tan formula. If this is minus on the top, we have to subtract. So we have tan alpha minus 2 alpha. Now purposely I have given you these values. Now you appreciate that this is equals to tan of minus alpha, which is minus tan alpha. Is that clear to you? So it's a huge concept. So do not interchange these angles. If you interchange them, then you might just get wrong answer. Perfect. Now I hope this concept is clear. And this formula of a plus ba minus b for cos, sine and tan is registered in your mind. Perfect. Let's move on and take question number 2 now. Question number 2. Express each as single trigonometric function. We have again 4 functions for you. Now the idea here is to understand double angle formula, right? So that is the second level which we'll get into. Now you already know the formulas. Let me rewrite them. We know sine A plus B is equal to sine A cos B plus cos A sin B, correct? Now what happens if I make B equals to A? So if I write B equals to A, then we get sine of A plus A, correct? B becomes A. And on this side, we get sine A cos A plus cos A sin A, perfect? And that means sine of 2A is equals to 2 times sine A cos A. So we get a double angle formula for sine. Do you see that part? Now similar operations can be done with cosine also. So let's see this. So if I have cos of A plus B, the formula is cos A cos B, but we have minus here, right? Minus sine A sine B. Now if I do B equals to A, then what do we get? We get cos of 2A equals to, both of them become A, right? Cos A. So it becomes cos square A minus sine square A. Do you see that part? So the cosine formula will be cos 2A equals to cos square A minus sine square A. Now I need another page to actually elaborate more on this particular double formula, I will cut it short and place it on this sheet itself. Now this formula, which is cos of 2a equals to cos square a minus sine square a, can be written in two different ways. If I write cos square a as 1 minus sine square a, we already have minus sine square a, then I get 1 minus 2 sine square a. Perfect. So I get formula number 2 for cosine of double angle. But if I change sine square a as 1 minus cos square a, then what? That is to say, cos 2a equals to cos square a minus 1 minus cos square a. Correct? So now I am changing sine square a as 1 minus cos square a. So minus 1, but minus and minus makes cos square a as positive. So we get 2 cos square a minus 1. So we get another formula for cos 2a. So we have three different formulas for cos 2a and we have one for sine 2a. Now these are going to help us to answer all the four questions. Plus we may have to do some factoring, right? So with that in mind, I'd like you to pause the video, find the answer of this and then check with my solution. So the very first one gives you difference of square of cos square and sine square with angle as 3 alpha. So what should that be equal to? Clearly, it is the first formula of cos 2a, cos square a minus sine square a, correct? And so double of 3 alpha will be 6 alpha. So what we get here is cos of 6 alpha. Is that clear to you? Perfect. Now the next one is to misguide you. Cos square a plus sine square a, you know, is just 1. That is a trigonometric idea, right? Pythagorean trigonometric identity. Cos square alpha plus sine square alpha is just 1. Okay, great. Now, the next question here is cos cube, okay, and sine square cos alpha. We could factor cos alpha. So if I factor cos alpha, I get cos square alpha minus sine square alpha. Now center portion, cos square alpha minus sine square alpha is cos 2 alpha and we have cos alpha here. So I could write this as equal to, so let me just write it up. We have space here. So we get this as cos alpha times cos of 2 alpha. Does it make sense to you, right? So at times you may have to factor and get the result. Now the last one here, sine alpha could be factored. Now if I factor sine alpha, then what do I get? I get 2 sine square alpha minus 1. So what should that be equal to? Well, we have 1 minus 2 sine square alpha. So this is equal to negative of sine alpha times sine 2 alpha. Is that clear to you? So I'd like you to make a note of this, that this becomes negative of this value. Do you see that part? So that is how we have to correctly answer these questions. However simple they may be, there is scope of making an error. Don't do that. Perfect. Right? So let's take a break here, watch the nature, and then come back and do the rest 3 questions. Here is question number 3. You need to evaluate exact value of the following. We have cos of 15 degrees and sine of 13 pi by 12. Now we could use compound angle to find cos of 15 degrees. Let's do it here. So we want to find what is cos of 15 degrees. I could always write 15 degrees as combination of 45 degrees minus 30 degrees. Does it make sense to you? Correct? And now we can use the compound angle formula, which you remember by now, which is cos of 45 degrees times cos of 30 degrees. Should I write plus or minus? If it is minus, we have to write opposite sign for cosine. Perfect. Sine of 45 degrees and sine of 30 degrees. Now we can always use our special triangles to get these values. So for 45 degrees, the angles are 45 and 45. So the sides are same. And we could always write this as 1 square root 2, right? Now 1 square root 2 sometimes gives us problem with rationalization. So it is preferred to take these values as square root 2, square root 2 and 2. Perfect. So these are the values which we are going to use for cos and sine. So we are going to write cos of 45 as square root 2 over 2, right? How about cos of 30? So I need to sketch the other triangle also, which is 30, 60, 90 triangle. In this triangle, the sides are in the ratio of 1, 2 and square root 3, where the angle 30 degrees is right there, right? So you could write 30 degrees or you could write pi by 6, right? So either way. Okay, so cos of 30 degrees, from here square root 3 over 2. So we get square root 3 over 2 minus sine 45 is square root 2 over 2 and sine 30 degrees is half. So we'll multiply this by half. And now what do we get? We get common denominator of 4, 2 times 2. In the numerator, we get square root 6 minus square root 2. So that is the value for cos of 15. So let me rewrite this answer as square root 6 minus square root 4 over 4. Correct? Now let's figure out how to find sine of 13 pi by 12. Okay. Now 13 pi by 12 means what? It means that the pi is divided into 12 portions and we are on the 13th one. That means we are in quadrant 3, where the acute angle is pi by 12. Perfect. And we also know sine is negative here because tan is positive, right? You can write down your rule by which you remember which is positive in which quadrant. We know sine definitely is negative here. So, and the acute angle is pi by 12. I could write this as sine of negative first because the sine is negative and the acute angle pi by 12. Perfect. So we'll work on minus sine of pi by 12. I'll leave this space to write the answer. We'll take it up right there. So we'll find what is minus sine of pi by 12. Now I could write pi by 12 as combination of what? Well, 4 minus 3. So we'll write this as 4 pi minus 3 pi by 12, which is same as minus sine of 4 divided by 12 is 3. So we get pi by 3 minus pi by 4. Okay. Now we can use the cosine formula and find the value. So we have negative outside. Let me make a bracket here. This is that negative. Sine A cos B. So we have sine of pi by 3 minus, minus comes later with cos of pi by 4 minus cos of pi by 3 sine of pi by 4. Is that clear, right? So square bracket. So let's substitute the values. We have negative value of sine pi by 3. So pi by 3 is this angle, right? So pi by 3 sine means opposite over hypotenuse, square root 3 over 2. Cos of pi by 4 is square root, we'll use this 2 over square root 2. Okay, so 2 over square root 2 minus, well, cos of pi by 3 will be half times sine of pi by 4 will be 2 square root 2. I should have written square root 2 over 2, sorry. Yeah, because we kind of took this value as 2 and square root for the sides, cos and sine values have to be less than 1, right? Okay, so that is how it is. Now we can just multiply, but negative outside. Again, denominator is 4 for us, and the numerator is square root of 6 minus square root of 2. So this is negative of square root of 6 minus square root of 2 divided by 4. Correct? So that is our answer. So for sine 13 pi by 12, we get negative square root of 6 minus square root of 2 divided by 4. Is that clear to you? So this value of cos of 15 and sine of 13 pi by 12 we can find from our special triangles, which were pi by 4, pi by 3 and pi by 6 angles. So combination formulas really help us to find exact values for many other angles. So I hope you understand and appreciate it. Let's move on to question number 4 now. Question number 4. Prove that cos of 3 pi by 2 minus x is equal to minus sine x. Well, as you know, we are looking for the angle in which quadrant? When I say 3 pi by 2, this is 3 pi by 2, right? Minus something, that means we are in this quadrant, correct? So that's the triangle. Now here, cos is negative. Perfect. And therefore, negative sine x makes sense. So we know it is the correct thing, but we need to prove it. We can prove it using compound angle formula. So we could write this as cos of 3 pi by 2 minus x can be equals to cos of 3 pi by 2, 3 pi by 2 cos x plus sine of 3 pi by 2 sine x. Correct? Now, for finding the angle 3 pi by 2, how do we do it? So best way is to sketch sine and cosine functions. So the sine function is kind of like this, the cosine function is like this. So as far as 3 pi by 2 is concerned, for sine it is negative 1 and for cosine it is 0, right? So that is 3 pi by 2. So when you substitute the value, here you get 0 times cos x, and here you get minus 1 times sine x. And therefore, what you get is minus sine x. Is that clear? So that is how you are going to prove it using the compound angle formulas. I hope it is absolutely clear. Now let's take the last question. Question number 5. We are almost at the end. Here is question number 5. If x and y are in the interval pi by 2 to pi, and sine x equals to 3 over 5 and cos y equals to minus 12 over 13, evaluate tan x minus y. Now remember, we are in quadrant 2. When I say that the interval is from pi by 2 to pi, it means we are in quadrant 2, correct? In quadrant 2, only sine is positive, right? Only sine is positive in quadrant 2. That is to be remembered. So what we are given here, we are given sine x as equals to 3 over 5. This reminds you of the right triangle 3, 4, 5, right? Let me just sketch it here. So sine value means this is 3, that is 5, and this is 4, and this angle is x. So clearly we have tan x, which will be 3 over 4. For the other triangle, which is given in cosine y, we have cos as 12 over 13. So basically it is kind of like this, where the hypotenuse is 13 and base is 2 for the angle y. Now here we are given that cos of y equals to minus 12 over 13, and so tan of y will be what? 13 square minus 12 square, square root gives us 5. So tan y is 5 over 12. So this is simple Pythagorean theorem which we have applied to get the third side. Now once we know that, it's kind of simpler for us to evaluate tan x minus y. We know the formula, which is tan of x minus y equals to tan x minus tan y, right, over 1 plus tan x tan y. So with this, you should be in a position to solve. So I like you to pause the video, answer, and then check your solution. So what we get here is tan of x minus y equals to tan x. So what is tan x? Let me rewrite this. So we have tan x minus tan y over 1 plus tan x tan y. So that is equal to tan of x is, well, both should be negative, because we are in quadrant 2. So don't leave them as positive. That was a mistake. I'm just making triangles on the side, but remember, quadrant is 2. And as I said, tan has to be negative. So both are negative, so we'll write here for tan x minus 3 over 4 minus of minus 12, minus 5 over 12, so 13, 5 over 12, okay. And in the denominator, we have 1 plus, both negative, minus 3 over 4 times 5 over 12. So both are negative, which makes it positive. Okay, great. So now we could take common denominator of 12 in the numerator. Now this becomes positive. Let me rewrite. So we have minus 3 over 4 plus 5 over 12, and the denominator here is 1 plus, let's multiply. 3 times 5 is 15 over 48, correct? Right. So that could be written as, here we have, we can take common denominator of 12, so it gets multiplied by 3. So we have minus 9 plus 5 divided by 12, and in the denominator we have 48 plus 15 divided by 48, correct? So this gives you minus 4, and here we have 5 and 8, 13, 3, 1, 63 times. This could be cancelled, so we get, well, let me write this as first 48 over 12. Now I will cancel, right? So we'll simplify this. That goes 4 times, correct? And this 4 will also cancel. Oh, so sorry. That goes 4 times here, and this 4 is like minus 4 there. So what do we have here is minus 16 over 63, correct? So that becomes the solution. We get tan x minus y as minus 16 over 63 as our answer. So this is minus 16 over 63. Don't do like what I did, right? Okay, anyway. So I hope you understand and appreciate how easy it is to use compound angle formulas. They actually make things simpler. Now in part 2 and 3, we'll look into double angle, half angle formulas, and also we'll look into the product to sum and sum to product variation, which is kind of tricky. So I hope part 1 is absolutely clear. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that will be great. Thanks for watching and all the best.